Hey, hello everyone. So today we'll be looking at this device. This is a tooth floss, water floss. So this one does not turn on. So this one has a 5-volt connector. Let's plug a connector first. Let me find a 5-volt connector to this one. So we couldn't find a good adapter for this one. All of these does not fit this device. I was going to use this, so let's take it apart and use the lab bench power supply to charge it. Okay, to take this apart we need to first get this water tank out. Then we have here 4 screws. Okay, so the screws are out. Let's open it. Okay, so here we have the pipe from the water tank going this way to the pump. Okay, so here we have the 18650 3.7 volt battery. Let's measure the voltage on this battery. We have how much? This is the ground going to this wire, and then we have the red wire going directly to the motor. So we have 3.8, which is good actually. This battery is fully charged. Let's take this motor out. Maybe the power button is just not good. Okay, so the motor is out. Let's have a look what underneath this cover. So we have a PCB here. Okay, let's have a look at the PCB and see if there is any corrosion or something. Let's take it apart first. So this is the PCB. We have here lamps. These may indicate the battery level or the strength of the water floss. Okay, so this wire is cut, actually the yellow one. Why it is cut? Okay, so let's have a look. there seems no corrosion on this board. So the voltage from the battery goes straight away to the positive, I mean, goes straight away to the motor, and from the motor to the PCB. But the ground side goes first to the PCB, and then from the PCB we get this yellow cable that goes to the motor. This motor is all rusted, it looks rusted. Let me just zoom in. Okay, so can we turn on this motor? Will it still run? Let's have a look. I will set the voltage to 3.7 volts. Let's turn on this motor and see if it does work. So the motor is working, as you can hear. But why doesn't it turn on? Let's connect this wire like this and try turning it on using this power button. So it does not turn on. Let's disconnect this cable and let's test this button. So these two, I think, are connected together. Actually not, maybe these two, yeah. And these two together. Yes, so if we connect between this one and press this button, we should get a continuity, we should get a beep. So the power button is working actually. So we might have a problem with the PCB. Maybe this is a motor driver. Okay, let's trace out how the signals goes to and from this PCB. Okay, so the signal first will enter from here. Let's bring this cable. The first wire is the ground, so this is also written here B minus, B plus, so battery minus, battery plus, and even in the cable we have black positive. Then we should have the motor C and W. The C is actually the charge, and this is the motor, which is, it should be M, not W. So as I said, the positive side is connected directly to the motor, but the negative side of the motor will go through this pin, which is W minus. So battery minus, battery plus, charge plus, and motor minus. So the motor is this one. Let's trace it. Where does it go? So first it goes through this, I mean not through this diode, but this way to these two transistors. So these transistors might be MOSFETs that turns on this motor, and they are connected in parallel. Okay, let's measure this pin with this pin and check, are they connected together? Yes, they are connected together. So they are connected in parallel. These two are together also. These two maybe not. They are, yeah. So these two are connected in parallel to drive the motor. If these two does not get the power, I mean the enable signal, they will not allow voltage to go to the motor. So the positive side is this one, goes here to this resistor and to this capacitor and then to this IC, and also it goes to this IC here. Okay, so this IC might the one that drive these two transistors. So here we have a trace. No, so it's not this one, it's this one. As you can see, we have a trace from here up to here. Yeah, and to here. So I don't know actually what are these ICs. They are not visible because of the conformal coating. So I need to take this coating so we can read these. ICs. There is no writing at all at this one. This one does have writing, but it's not really visible. LP 40568 maybe. I don't know. Let's connect the power. So this is the charging IC I was talking about. This is a power supply that is used to charge the battery. Okay, so I am measuring from here. This is the ground to the positive, which is this one. We should see something around 3.7 volts, which I didn't see until now. I have nothing. Let's connect the ground here. 3.8 from this ground, but from the ground. Okay, so here is the battery. It has circuitry over there. So this circuit is, I think, what is faulty, because when I'm measuring the voltage from this ground trace to the positive side, which is this one here, we get the voltage, which is 3.8 volts. As you can see, we have voltage. But if I measure from this and this one, this ground and this VC7, this one, we get nothing. So we have something wrong in this circuit, actually, not this circuit. That is why this device is not working. So let's disconnect this again and let's have a look at this circuit. Let's go to the main camera for a while. Okay, so actually there is a circuit here at this battery. So we need to take this circuit out and test it, why it is not allowing voltage to go, I mean allowing the minus to go out of this circuit. This is actually a protection circuit, So how do we take it out? I can see rust, so it might be rusted, that's why it's not working. Can we take this out? Okay, so it is disconnected. Now, as you can see, we have this circuit board. And this is the connection to the ground, and this is the positive side, which is connected directly, as you can see. Let me just adjust the focus here. So as you can see, we have here where we disconnected the battery, P plus is connected directly to this wire, so it is going straight away to the positive line. But the negative side, as you can see, it's not connected directly here. That is why we are not getting the minus from here. When I measured here, we have the voltage, but when I'm measuring here, we didn't see that voltage. So something here is causing this battery to go in a protection mode. So either one of these is faulty or might be this one. So first let me check. I think it's from this side. Yeah, we can see these vias here, and we can see those vias over there. So if we check from here in continuity mode, so we have, yeah, as you can see, it is going there. So these are from this side are connected here straight away to the negative side of the battery, and from this side they are connected to the negative wire. So what turns on these two is this IC. As you can see, we have this pin in here, and this pin, and that pin, and that pin. These two are connected together, and these two, maybe, let's check here, they are not ground, maybe going somewhere in the IC. Maybe they are not going anywhere, just there. They are connected together. If we check this one, okay, we check this one, I think it's going here. Yes, is it going here also? Yeah, so these two are connected together to this IC. So either this IC is faulty, which is not driving these two, or these two are faulty. So if we check from here to here, we have nothing. To this one, the control, we have nothing. These two are connected together, these two and these two. Okay, and this one to here, to there, they are not connected. there's no short. So let's measure these two resistors. This one is 1000, so it's 1K, and we are reading 1K. This one is 100 ohms, and we are reading 100 ohms. So it might be this IC is faulty, DW01. I need to find the datasheet of this IC and check. I don't know what is this. Why don't we just clean it and try it? Now if I connect this here, can we turn on, or we can measure the voltage? Okay, let's go to voltage mode and measure from here. Let's connect the PC and put one probe here, one probe there. It's better to go to the main camera and you can see what I am doing. Okay. Okay, now let's connect this and measure. We still have nothing. Let's do it again. Nothing at all. Okay, so I need to find the datasheet of that IC, little IC. Let's just find it. So yes, this is a battery protection IC, is DW01. So this is the datasheet of it. So here is the pin out, I mean, so pin number 1 is OD MOSFET gate connection pin for discharge control. CS input pin for current sense. OC, which is MOSFET gate connection pin for charge control. So this is for discharge control and this is for charge control. So we have OD and OC, charge, discharge. Okay, so and we have the TD, test pin for reduced delay time, VCC supply with through a resistor R1. Where is R1? VCC through, maybe it's on the board, and ground. So we have 5 volt. Let's go back to the main camera. I will solder a wire from there to here, so I will solder a wire from there, from here to here, so I can measure the voltages there. But I'm pretty sure that this IC is faulty. I will need to find a replacement IC, but let's first solder a wire. Okay, now if we measure, we should see some voltages on this circuit. So this is the ground. If we check here, we have 3.8. So after this resistor, how much do we get? We have 3.8. So it's going to VCC bin, maybe. VCC bin is the 5 bin, number 5. So it should be, where is pin number 1? Is it this? Yeah, this one. 1, 2, 3, 4, 5. So it's this one. We should see 3.8 volt at this pin. And we do, yeah, 3.8 volts. So discharge bin, we need to look at the discharge bin, which is the bin number 1. This is the control bin of the discharge. We have nothing. That is why we don't have anything here. Yeah, so this might be faulty. If we check bin number 2, which is the current sense, 2.6 volts. Bin number 3, output control, or I mean charge control, we have 3.8. Here we have 2.6 volts. But if I measure from here to here, I have 1 volt right now. Why am I having 1 volt? Can we turn on this? No, we can't. We still can't turn on that board. Let me solder these 2 wires. Now if we measure from here to here, we have 1.17 volt. We still can't turn on this device. From here to there we have we have that 1 volt. So why we are getting only 1 volt? It's because of this device. I am pretty sure, actually. Let me find a replacement and we will change it if I do have. Unfortunately, I couldn't find this IC, so I don't have it. For now, what I could do is I can short these 2 pins together and we can use this device until this device arrives, until this component arrives. So let's do it, and we will fix this when we get this device. Okay, so we need a piece of wire. We can use a wire braid. Let's disconnect this one. Okay, now we can stick this here. Okay, so we can use it like that for now. Now if I connect this back, let's try and turn on this motor. Yes, as you can see, microscope. So you see we have a light here and the motor is turning on. I disconnected right now. Let's connect it again. Let's turn it on. Let's try to increase the speed. So it is working. So there's nothing wrong with this board. It's actually this protection board only. I will order that part, and once it arrives I will install it and remove this jumper wire I made. Okay, let me just take a picture of this. Now we can solder this back. Okay, so let's put it together, and this device is fixed for now, at least. So it is working, yeah. Let's put this back. Okay, so here it is. It's all working again. Of course, we need to change that protection IC, but now it is working. Yeah, so that's it. Thank you for watching, and I hope I can see you in another video. Thank you so much.